In this video, we are going to graph some functions. We're going to graph these linear functions, and we're also going to graph some absolute value functions and see how those compare. And then we're going to graph some piecewise functions and see what those look like. So that's what this video is about. All right, when we have a linear equation like this, I'm thinking of y equals mx plus b. So the b is the y-intercept, which in this case is -1. So I'm going to put my first point at -1. Then the slope is -2/3. Now think of it as -2 over 3. So when I do my rise and my run, I'm going to go down 2 and right 3. So repeat that, down 2, right 3. I can put more points to the left by going up 2, left 3, repeat, repeat, repeat. So this is what the graph for problem number 1 is going to look like. Okay, looking at problem number 2. I'm going to rewrite this in slope-intercept form first. So if I have 5x minus 2y is equal to -8. First thing you want to do is subtract 5x from both sides. So that will leave you with -2y is equal to -5x minus 8. Now to get y by itself, you want to divide by -2. And you want to do that in all three of these places. So that's going to give you y equals positive 5 over 2. A negative divided by a negative is a positive. And plus 4. A negative divided by a negative is a positive. So I see the y-intercept is 4, which goes here. Rise over run, so up 5, right 2. 1, 2, 3, 4, whoops. 1, 2, 3, 4. So, okay, so it's a little bit off the graph. So up 5, right 2. It's going to be like that. And I can repeat this process to the left by going down 5, left 2. So here I go, down 5, left 2, and down 5, left 2. So this is what this line should look like. Now, when we get to problem number 3, you see this absolute value symbol, all right? These vertical lines, that means absolute value. Absolute value functions are going to be always in the shape of a V. If it's positive in the front here, it's going to be an upward facing V. But see how this one is negative? I know then I will have a downward facing V like that. Now, the parent function, which is just the absolute value of x, the v always started at the origin, and then it went from there. So when we think in terms of transformations, this plus 6 on the end means up 6. So instead of being at the origin, my vertex is going to be here. And again, I know this is an upside down v, so it's going to go from here. Specifically, I can use this -3 to find the right-hand side. Treat it as the slope. So this is down 3, right 1. So down 3, right 1, again, again, again. Now this is going to be a V, so I'll do the mirror image. Down 3, left 1. All right, so this is what number 3 should look like. All right, I know these lines are really crooked, but with these electronic pens, it's hard to avoid. Now the domain and range over here, this goes left and right forever, so -infinity to +infinity. Now range is from bottom to top, the y value, so it goes down forever, so -infinity, and it goes up to a height of 6. And we'll put a square bracket on it to show that the 6 is included. All right, now let's move over to number 4. Now, this plus 2 is actually going to shift the graph left 2. So this is left 2, up 5. All right, the left-right motion is always the opposite of what it looks. So left 2 and up 5. So my vertex is going to be right here. All right, so this graph is going to barely fit because now the slope is 1 over 1. So that means up 1, right 1, and I'm already out of space. I could maybe squeeze in one more. And then on the left side, it should be the mirror image, so up 1, left 1. All right, so there's just space for this teeny tiny little graph right at the top of the screen. So that's the best we can do with this particular set of graph paper. Okay. Now the domain and range. The domain, again, will be negative infinity to positive infinity, left and right forever. The range is the y values from bottom to top. So the lowest value is at 5, and then it goes up forever. So 5 to infinity. All right, let's find problem number 5. So now we're going to graph this piecewise function. So let's graph this part first. So think y equals 1/4 x minus 4. So I could go to negative 4 as my y-intercept. Now 1 over 4, that means up 1, right 4, up 1, right 4. I could put more points to the left by going down 1, left 4, down 1, left 4, down 1, left 4. So these points show me where the line y equals 1/4 x minus 4 is. But we're only going to graph the part of the line where the x values are less than or equal to negative 4. So which one of these dots has an x value of negative 4? Not this one. That's a y value of negative 4. X value of negative 4 is over here. So this is the endpoint for this piece. Now, less than negative 4 would be to the left. So I'm going to draw the left part of this line, which goes like this. And I will erase these extra dots. So that's the first piece of this graph. Now, y equals negative x plus 1. That would start at positive 1 because of the y-intercept. Negative x means negative 1 over 1. So that's down 1, right 1. And I can get more points going to the left. Just follow the pattern. Okay, now we're not going to draw the whole line. We're just going to draw the part where the x values are greater than negative 4. So even though it says greater than negative 4, which does not include negative 4, still find which one of these dots has an x value of negative 4. All right, don't go to negative 3 or anything like that. Go to negative 4. So this is the point that is at an x value of negative 4. Okay, now the way so this is going to be the end point. But the way we'll show that it can't equal negative 4 is we'll make it an open circle. All right, there. The negative 4 is not included. Now this is greater than, so that means to the right, which is why I'm going to graph this, this side of the line. And we'll erase any extra marks. And that's it. So that's what this function should look like. Now the domain is still going to be negative infinity to positive infinity. The range is y values, so bottom to top. This goes down forever, so negative infinity. And it goes up to a height of 5. All right, this is the top value at 5. So I'm going to put 5. Now because this is an open circle, I'm going to use a parenthesis instead of a bracket. So that's it for this piecewise function. Let's slide over and take a look at number 6, and this will be the last one in this video. Now, when I look at these little equations that I would have, so I would have y equals 1, for example. Y equals 1 is just a horizontal line at 1, right? So these are all horizontal lines. So this is what the line y equals 1 would look like. Okay, got a little crooked there, but you get the idea. Horizontal line. So we're going to graph the part of that line that is between -8 and -4. So here's -8, and here's -4, and here's the part of the graph that's between those points. Still making them crooked. The left side is going to be a closed circle. All right, because it says or equal to -8. So -8 gets to be included. All right, now let's do the next piece. So we're thinking y equals 5. So that's going to be a horizontal line at 5. But we're only going to graph the part of that line that's between -4 and 2. So here's -4, and here is 2. And here are the points between -4 and 2. Now again, the -4 side is going to be a closed circle. Closed circle, open circle, because of the or equal to, and this side doesn't have it. So that's what the middle piece looks like. So finally, for y equals 9, that's going to be a horizontal line at 9, like this. But we're only going to graph the part that's between 2 and 6. So here's 2, and here is 6. And then here's between 2 and 6. All right, so this is what your graph for number 6 should look like. Now let's just talk about domain and range. The domain, this does not go left forever. So left to right, wait, I forgot to make this a closed circle because of the or equal to. On the left, the point on the far left is at an x value of -8. So I'm going to put -8 here for the domain. On the right, the graph stops at +6. Now that's an open circle, not included, so I'll use a parenthesis. So that's the domain. I can use interval notation because no x values are missing. This blue part goes from -8 to -4, and then the red part picks up immediately at -4. There are no missing x values between -8 and 6. Now the range, we cannot use interval notation. I can't just say, okay, the lowest is 1, the highest is 9, so I can't just say, oh, okay, it'll be 1 to 9, or whatever. Like, you can't do that because of all the gaps. There are no y values in between here, and there are no y values, the 6, 7, 8, there are no y values in here. In fact, this whole graph only has 3 y values. And they are 1, okay, all this blue stuff is at 1, and then 5, and then 9. Those are the only y values in this graph. So you just list them and use braces like that. Alright, that's going to be the end of this video. I hope it was helpful, and I will see you on the next video.